Okay, so in this video, I am going to cover multiple regression, just a basic multiple regression where we have multiple independent variables that are all quantitative, and we have one dependent variable, which is also quantitative. So when you run a multiple regression in Excel, it's really easy if you know how to run a simple linear regression because you're going to cover the same exact steps. But you need to have your independent variables all side by side in Excel because when you highlight your X range, you're going to highlight them all together in one swoop. So let me show you how to do this. We're going to conduct a multiple regression using that same data set from the previous video. Our independent variables are going to be show trust in me, communicates what is expected of me, and cares about me as a person. Those are our independent variables. And then happy is going to be the dependent variable. So let me pull the data set up. Here it is. And I'm going to go to data analysis, regression. I'm going to clear all this stuff out. So our Y range, that's happy. So I'm going to click on the label happy down to the bottom value. You can try to do this really quickly in a big data set. Try holding down Shift Control down arrow, and it will highlight the whole column until you have a blank, like until it recognizes a blank cell. So you just want to scroll down and make sure it really did cover everything. Because if you have any blanks, it will stop. And remember, you can't have any blanks for a regression. If you have a blank, you need to delete the whole row. For the Y range, I'm going to highlight all of my predictors together. Okay, doesn't look like I had any blanks. Make sure labels is checked once again because we did highlight the labels at the top, which you definitely want to do. Click OK. So here is our output. Okay, so you'll see this in the slides. So I'm going to go back over to the slides. Okay, so the big difference that you're going to notice in this output is this bottom table. Notice you have more rows here. More t-tests were done. You have more coefficients. Look at the labels. You should see your predictors all listed out here. So for each predictor, you're going to have a coefficient, a standard error, a t-test statistic, a p-value, and a confidence interval. And everything else up here is kind of the same thing that we talked about from simple linear regression. The R squared, that's one thing I want to point out. It's 0.24. That tells us that all of these predictors together explain 24% of the variation in happiness. So that's really good. That's a pretty good amount. There's still about 76% left to explain, but 24% is a good chunk when it comes to things like this. Our sample size, 693 N. Remember, N is the symbol for your sample size. Then for our F-test, we have our F-test statistic here and our p-value. Now remember that e to the negative 41, we're moving that decimal place to the left 41 times. This is a really small p-value. So since our p-value is less than 0.05 alpha, we're going to conclude there is a relationship. Now the F-test, I want you to know this. The F-test tests the entire model. So all three predictors together do significantly predict happiness. That's what that tells us. When you go on down to the t-test, the t-test tests each predictor separately. So you're going to look at these p-values that I've circled in red. This one's less than 0.05. This one's less than 0.05. This one is more than 0.05. That is telling us that show trust in me and communicates what is expected of me. Those two predictors significantly predict happiness. whereas cares about me as a person does not. And that's consistent with what we found in the simple linear regression. Cares about me as a person did not significantly predict happiness. So that is informative here. We know which specific predictors predict happiness. Okay, so it might make sense here to use the line equation to predict happiness since we did have some significant results. So this is an example of our line equation that you see here on the bottom left. Y equals BO. Remember, the BO is the y-intercept. You have one of those over here, which is that 1.62 right next to the word intercept. Plus, now you are going to see a slope times x for each predictor in your model. We have 3 predictors here. So we're going to need to plug in 3 slopes and then 3 values of x. So the slope for our first predictor is over here under coefficients, 0.39. So I have 0.39 times x1 plus this 0.53. I'm just rounding 2 places past the decimal point in all of this. So 0.53 times x2 plus down here 0.02 times x3. I guess that technically should have been 0.01, but yeah, you get the point. And you don't have to round. It's best if you use the precise values here, but just for simplicity purposes, I've rounded. So if you can plug in a certain value, so you can say, hey, I have this new employee. They filled out this survey. They had a show trust rating of 3. So I'm going to plug in 3 for X1. They had a communicates what is expected of me value of 4. So I'm going to plug in 4 for X2. And they had a care about me as a person value of 1. So I'm going to plug in 1 for X3. Do the math, and you can predict what their happiness is going to be. So that's multiple regression. The next thing I want to cover is how to write a technical report of your regression results. And I am going to add something here to one of these, but let's start with the simple linear regression that we did in the last video. A simple linear regression, you're going to write up the results in a way like this. A simple linear regression was conducted to predict happiness ratings, our DV, based on our IV, ratings of whether their manager cared about them as a person. Then you're going to say an insignificant regression equation, or significant, depending on your finding, was found. You're going to open parentheses and put F. Open parentheses again. These are your 2 degrees of freedom. So the first 2 numbers under DF in your output. Equal, close parentheses, equals. This is going to be your F test statistic, rounded 2 places past the decimal point. You do want to round here. 2 places past the decimal point consistently. Comma, P. Your P needs to be italicized and lowercase. Either a greater than or less than sign, 0.05. If you want to be a little more conservative, you could use 0.01 as alpha, or even 0.001 if it's like a life or death situation. But typically 0.05 is used. You do not need to put the exact p-value, just put if it's greater than or less than 0.05. So then you're going to close parentheses, comma, with an r squared. Make sure that 2 is superscript, and it should be italicized, of point whatever, round 2 places past the decimal point. Let me point out where those values are. Going back to our simple linear regression, 1,691, that's our DF, our degrees of freedom. Our F test statistic is here, the 0.02. Our p-value was here. It was more than 0.05. And then our r squared is here. It was, you move the decimal place to the left 5 times because of this e to the negative 5. So it was pretty much 0. So that's where those numbers come from in this first write-up. Now with the multiple regression, it's gonna be kind of similar. I'm actually gonna add something to this. A multiple regression was conducted to predict happiness ratings, our dependent variable, based on the three predictors. So their ratings of their managers' caring, communication, and trust. A significant regression equation was found. F, in parentheses, you're putting the 2 degrees of freedom, equals, this is your F test statistic, 72.99. And in this case, the p-value was less than 0.05. And our r squared was 0.24. So you want to follow this as closely as possible. Um, you know, keep the formatting the same. You're kind of just updating your variable names and your numbers, but you can pretty much use this as a template. Now, what I would like to see added to this multiple regression report is another sentence saying which specific predictors were significant from the t-tests. So I would add something like um, communication and trust um, were uniquely significant predictors based on t tests, and you can put p is less than 0.05. And I did get that right. I think it was communication and trust. Yes. So you're going to want to have that follow-up sentence in there. But yeah, that's pretty much covers how to write up the results of a regression. So you're going to use this for the projects.